Hello, this is E.J. Daigle, Dean of Robotics and Manufacturing, and this will be the second lecture on the sequence of working with MicroBasic Script. So let's go ahead and get at this. Okay, for my students that are going through this in class right now, and we're doing this course online at the moment, there are three things, and I did a short video on how to get these three things, but it is imperative that you've downloaded and installed the Robo AGV Sim software. You probably have a desktop icon now that says Robo AGV Sim. You download and utilize the Visit 3 Locations map, and then download and utilize the Minibot AGV Sim profile, and I'll show you guys that in a minute. I also have on Canvas went ahead, and when you look at this week's stuff, I'll open this up today yet. It's not published yet just because I'm finishing up this video. I've got an intro video for the week that you can watch. I've got a video lecture that goes through installing the software, the profile, and all those things. And then I have this video lecture, which is our MicroBasic programming lecture. I also have a homework lab. And when you go into this, you'll actually be able to see that the files are here. If you forget and don't get any of that other stuff downloaded, you can always get these files in here as well. This is a zip file from where you can install the Robo AGV Sim software. These you'd have to store in a location where you're saving your Robo files as you build them. If you save them in there, you'll be able to open them up though then from Robo AGV Sim. And then this will be the homework that you'll complete this week. Once you're done with all of that, you've been through all the videos, you've been through the homework, there will be a weekly quiz I haven't published yet, but that'll get published today as well. So this is for the week of 3:30 through 4:3. I'm not defining set due dates. Like our course would normally meet Tuesday and Thursday, but with us going online now, I'm not going to set a Tuesday item that's due and a Thursday item that's due. I am going to ask you though to, as you have time throughout the week, make sure you're working on this stuff. So I've got essentially 5 things listed there. You may want to work on this one on Monday, this one on Tuesday, Wednesday, Thursday, Friday. They'll all be due at the end of the week. So don't worry too much about that. However, and I see this one says March 27th, so that won't be true. They'll all be due March 31st at 11:59 p.m. So don't get too or not March 31st. They'll be due, I guess it's April 3rd at 11:59 p.m. So I'll change those to all be due at that time. So the latest and greatest information will be available on Canvas. But make sure you are working. It doesn't bother me if you wanna work on them all, on Monday and get them all done and be done with this course. So you can work on other stuff. That's fine with me. It doesn't bother me in the least. So just make sure you are working ahead on that stuff and keeping up on it, making sure at least at a minimum. I have to have that lab turned in and I have to have the quiz done by Friday at 11:59 p.m. All right, so that's the first and foremost thing is number one, to download and install. If you watch the video, it'll go through that pretty well, the intro video for the week. Download and utilize the Visit 3 Locations map, and then download and utilize the Minibot AGV profile. So those are all pretty easy to use. All right, let's get into MicroBasic a little bit. One of the things about the MicroBasic programming language is this. We only get 2 data types. So we only get Boolean and integer data types. So I know there's a question on one of the sheets about pros and cons of that. So obviously one of the pros into going down to 2 data types is that we get faster execution. So by having less data types, let's see here. There we go. Faster execution. And we may not, be worried when we're doing, I don't know, like PLC where it's, very, state-based systems, or we may not be worried about, the thermostat in my house, how quickly it responds. But we're talking about an auto-guided vehicle. The ability for an auto-guided vehicle to react, whether it be to an ultrasonic sensor, a radar sensor, or some sort of LiDAR sensor, that's going to be very important for the safety of personnel working, in a cobot environment where we're collaborating with robots. Also for the sake of maintaining minimal amount of air. So if I allow the air to accumulate, now I've got a lot bigger correction to make than if I make a smaller correction every time I see a little bit of error. All right, so we'll talk about that in some of the future lessons on PID and things like that. What are some of the cons? Well, one of the obvious cons is we only can work with integer math. You might say, well, integer math is good. Well, yeah, integer math is good as long as it's things like 1 plus 1 and 3 minus 1 and things like that. But I'll give you an example of where integer math can fail you, for example. So as an example here, if I take this 10 divided by 20, and I'm going to store this in an integer location, and I'm going to store the result of this in an integer location. We know that 10 divided by 20 is normally going to be 0.5, but realize when I'm dealing with integer math, I cannot store or deal with decimal numbers. So what that means is decimal numbers are truncated. So 0.5 would be equal to 0. 0.7 would be equal to 0. 1.2 would be equal to 1. So in this case, 0.5 is going to become 0 times 1,000, which equals 0. This is the problem with integer math. So this can be the problem. Now, there are ways you can take care of that, of course, right? So if we don't want to deal with integer math, what we might do is we might say, well, let's take, let's do the math a little bit differently. Let's take 10 and multiply it by 1,000. We get 10,000, and divide that by 20, we get 500. And now we see that essentially, when we're talking about the sequence of mathematics, these are the same problem. Example 1 and example 2 should both result mathematically in a case of 500 because 0.5 times 1,000 should be 500. But the only thing that caused me an issue was the fact that this result right here could only be stored as an integer. And because of that, it's going to truncate down to the number 0. Versus up here, I have no problem writing the number 10,000. That's an integer. And divide that by 20 and get my result of 500, and I'm a happy camper. So be careful when using integers to calculate math that results in rational or fractional or decimal results, because that could throw you for a loop there. You'll see a lot of this stuff where we might multiply an integer by 1,000 before doing a division of some sort. All right, the next thing that's important to cover is the difference between open loop and closed loop control. For everything that we do for the lab 1 here, everything will be open loop. All I'm trying to get you to do is get used to the software this week a little bit, meaning you're not going to write any crazy codes. I'll talk about for next loops and if then and stuff like that, but you probably won't even have to use those this week. Open loop control means this. I'm going to tell the motors to do something, and I'm not going to monitor to see what they're actually doing. I'm going to assume if I tell this motor to go 250 RPMs, that it's going 250 RPMs. There is no slippage. There is no reduced voltage, reduced current. I assume that it's going 250 RPMs. Now, you know as well as I do that doesn't work out so well in the real world, right? Because in the real world, we have variables that might constrain the ability to do that. So you think of setting your cruise control in your car at 55 miles per hour. As the car hits the hill, it needs to know that, well, I hit a hill and I'm slowing down a little bit, so I need to speed up. That is closed loop feedback. That's the ability to monitor that not only did I set my set point to 55 miles an hour, but my actual measured variable that we're actually traveling at is 55 miles an hour. And so if I slow down, I speed up a little bit. I might set my set point to 57 to be able to maintain 55 miles an hour going uphill. But I might set my set point to 50 to maintain 55 miles an hour going downhill. So that's the benefit of closed loop. When we're dealing with open loop right here, a lot of times we don't have feedback. Well, we never have feedback, right? A lot of times this is done with things like timed events. So you could say in your house you have your thermostat and you just want to turn your heat on full blast every morning at 7 a.m. or at 6 a.m. because you get up at 6 a.m. and you want it to be warm when you get up in the morning, and that may work fine in January. But as we know, when we get to March and April, there may be mornings where it's already 70 degrees in your house and you don't need to blast the furnace. And there'll be mornings where it's 30 degrees and you may need to blast the furnace. So a timed event where you just turn something on with no recollection. I've got even a better example of a timed event here of open loop control. So I've got a timer on the lights around our house, and it's just a timer is all it is. And I set it right now. It turns the lights on at 6:30 p.m. every night outside, and it keeps them on for a few hours. So if you know, from 6:30 to 10:30 they're on, and at 10:30 they may turn off or something like that. That works really good the day that I set it, the day that the sun goes down at 6:30, and I keep it on until 10:30. But as the days get longer, now all of a sudden my lights are turning on at 6:30 and it's still bright outside. The sun hasn't set yet. You know, daylight savings can throw that into a mix. So it'd be better if instead of relying on a timed event, I had some sort of feedback that would tell me, hey, it's already light outside. You don't need to turn on at 6:30. I'll turn them on when it gets dark, and then I'll turn them off at 10:30. So what that means is we have error. And error tends to stack up when we're talking about an auto-guided vehicle or a robot or even a CNC machine. Error tends to stack up if you don't have feedback that I told you to do this and you're off by a little bit, so I'm going to make a correction. Open loop doesn't allow for that correction. There is no feedback. There is no correction. It's just a blind do this and hope that something happens. Closed loop control, by contrast, is a feedback loop. So when you look over here, my control unit says, hey, I want the motor to go at a certain speed. The motor then is going to send feedback saying, hey, I've been commanded to go 100 RPMs, but I'm actually going 90 RPMs. So then what the control unit can do is it can say, hey, let's go ahead and add 10 RPMs to this. So instead of telling it to go 100, we're going to tell it to go 110, and now I'm actually going 100. Versus up here, if I did that, if I told it to go 100 and it was actually only going 90, I would have no way of knowing that. I told it to go 100 and I'm assuming it's going 100. There is no account for errors. Down here, when we deal with closed loop control, we have a feedback mechanism. You know, this could be a tachometer that's measuring the RPMs. It could be a temperature sensor that's measuring the temperature in my house. It could be a photoelectric sensor that's measuring the light outside so I don't turn my lights on when I don't need them. That is a feedback control loop. All right, now let's get into what we're going to actually do inside of MicroBasic. So this is going to be the command that you're going to want to know right now. This set command is what you're going to need for actually turning the motors on your AGV. It doesn't matter that we're only doing it in a simulated environment. It's the exact same command for when we're doing it with the actual Minibot. So what we're doing here is we're actually setting a command, set command, and when we talk about separate control, when we set up our configuration window, we can select, do we want the motors to be a separate control or a mixed mode? And I don't get into mixed mode 2 and 3 and so on and so forth, but you can mix these in different ways. We're only going to worry about the first two here, separate or mixed mode. When it comes to separate control, the way I think about this is I think about this kind of like almost like a tank drive or maybe a Bobcat or something like that. Basically, each one of these channels, you set the command and think of this G as my output to the motor. It's kind of like a go command. And this is going to be channel number 1 on my controller. And I'm setting it to 450. And I can set that between 0 and 500. So I'm saying motor 1, I want you to go at 450. And oh, by the way, I want motor 2, channel 2, to go at 450. So the green represents comments. Remember, these are just comments we call them human readables or just comments. We signify comments in our code with just a little apostrophe there. Just not a quotation, but just a little apostrophe there. So set command channel 1 to 450, set command channel 2 to 450, and the vehicle is going to drive straight. Why is it going to drive straight? Because the two motors are going at the same speed. If you were to think about this vehicle here, and it's going to go, let's say these are my tires, and I'm going to go in this direction. If this wheel is spinning faster, say it's spinning at 500 and this wheel's spinning at 250, then it's pretty obvious this thing's going to want to turn that way. And vice versa if they're going the other way. Right now, because they're 450 and 450, I'm going to drive that vehicle straight. That would be separate control. This is good. Okay, this works good, and there may be times when this is the best choice. For most of what we're going to do, I'm going to recommend the mixed mode. I think the mixed mode's a little bit easier to control. So we'll stick with mixed mode 1 is what we'll use right over here. And let's talk about what mixed mode 1 does. We still have what's called channel 1 and channel 2. But instead of them being motor 1 and motor 2, we're setting a command now where channel 1 or command 1 represents the throttle. So this is the speed setting. This is how fast I want to go. And then channel 2 represents my steering. All right. Because my steering is set to a 0 right now, I'm going to drive straight. All right. So steering set to a 0. I've got my little mini bot here. Here's my tires. My mini bot's going to drive straight because my steering is set to a 0. Now, you think of this kind of like the XY coordinate system. If I look at the XY coordinate system, here's X and here's Y. If we talk about like an angle theta, that angle theta goes up in the positive direction here and the negative direction here. So if I want my vehicle to turn right, at least this is the way I think about it. If I want my vehicle to turn in this direction, down like this, then because I'm going in the negative direction, I would change this from a 0 to a negative number, like maybe negative 100. Now all of a sudden I'm still going at 450 for the speed, but negative 100 allows me to turn this way in maybe I'll call that a clockwise direction. And a positive direction on that number would allow me to turn this way. Just kind of like that. I use the XY coordinate system to imagine that angle theta, and that increasing or decreasing as it goes. So that should at least help you understand mixed mode versus separate motor control. And we're going to demo this in a minute. So if this is still it should be a little bit shaky right now, but we'll get it down cold here. All right, a couple of the statements that are most common in programming. MicroBasic is part of the basic family of programming languages. So things like if then, for next, do while, wait instructions, timing instructions, all of these are available to us. I'm going to go over a couple of them just because you'll see these on the quiz. And I just want to start to introduce them. If then statement. If then is what we call a conditional statement. I don't know that I want to read this big long verbiage here, but what it essentially means is this. I start out with an if statement, and we'll call DN a digital input. If the digital input is true, then I'm going to set my throttle to 500 and my steering to 0. Essentially, I'm going to drive straight, right? That's what I'm going to do here. Drive straight if this is true. Now, for an if-then statement, if this is true, I do what's inside this if statement. If DN1 is not true, then I skip this chunk of the if-then statement and I go to the next chunk and I ask a question again. It's conditional, meaning if this condition is true, do this. If that condition is not true, go to the next one. Else if. So if this, else, let's look at this. Else if means else if this is true. If digital input 2 is true, then I'm going to set my throttle to 250 and I'm going to start turning to the right with negative 100. So that's another thing I can do. So if digital input 1 is on, I drive straight. If digital input 2 is on, I turn right. Okay? And now these nest together is what they do. So let's say that digital input 1 is true, I'm driving straight, and then it's no longer true. Now I look and see, is digital input 2 true? Oh, it is? Okay, let's turn right. Now I'm in this chunk of code. Now the question is, what if neither one of these are true? If digital input 1 is false, I skip this chunk of code and I go to the next one. If digital input 2 is false, I skip this chunk of code and I go to the next one. And I say else if digital input 1 is false and digital input 2 is false, set my throttle to 0 and set my steering to 0. Oh, and also set digital output 1 to true. Maybe this is an LED or something to tell me that the vehicle is now stopped. And then all of these are going to end up with an end if at the end. So if this is true, I do this. Else, if this is true, I do this. Else, if this is true, I do this. And we can obviously say that, if it's a digital input, and I only have 2 possible scenarios, right? Well, I guess I didn't do one where true and true, but realize these are going to take priority. So if digital input 1 is true, I'm actually not looking to look at digital input 2. I'm going to stay in this state up here. Else I'm going to this state, and if neither one of these two are true, then the condition is going to fall down here. So I've either got DN1 on and hopefully DN2 off, or maybe I have DN1 off and DN2 on, or maybe I have both of them off. I have not taken a true standpoint to what happens if both of them are on, but in this particular case, the if-then does do that by saying, well, if both of them are on, I'm prioritized on this one because it's the first one I'm going to execute. Now, how does that compare to a looping instruction? Well, a looping instruction is quite different. So a for next is what we call a looping. So I like this little statement here. New style of for next statement optimized to work with Robotech controllers is recommended to be used. Same semantics as C++ for loop, but with a different syntax. So what this means is when you look at a for next loop, we say, okay, we've got an integer. For, I've created this integer. I've defined in memory up here somewhere int1 as integer. Okay, so that's defined up somewhere above. Don't worry about that right now. It's not irrelevant. But for int1 equals 0, and while int1 is less than 10, we're going to drive straight because we're going to set this to 450 and set this to 0. As long as we're in mixed mode again. If we're in separate, we're going to be taking a hard right turn because this motor isn't even turning. But we'll assume we're going to always be dealing with mixed mode at this point. And then I'm going to wait 1,000 milliseconds. And then I'm going to go next. So essentially, I've waited a second. I've set this. I've waited 1 second. And now next is going to increment the integer. So now the integer is no longer 0. Now the integer is a 1. And while integer 1 is less than 10, I'm going to set this to this. I'm going to wait 1,000 seconds. And then I'm going to loop again. So I'm going down this way. And then I'm looping back. But now the integer is going to increment to a 2. Boom, boom. Then the integer is going to increment to a 3. And so on and so forth. And it'll do it for 10 iterations. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When it gets to 10, I'm no longer less than 10. I'm going to skip this loop and go down to whatever that next chunk of code is underneath the next. So I'm going to continuously loop through this thing. I should turn my eraser on here for a second here. Pointer options eraser. There it is. So I'll erase this real quick, give you guys something cleaner to look at. So what's going to happen is I'm going to loop through this code from 0 to 9. So pointer options pen. So I'm going to go through this code, I'm going to wait, and then I'm going to loop back. And then this integer is going to go from 0 to 1. I'm going to do the same thing. I'm going to loop back. Then it's going to go to 2. And I'm going to keep doing that until I get up to, let's say, 9. I'll do ... I'm going to get up to 9 now. I'm looping back, right? And 9, I'm still good. I'm going to go down through the code. Now I'm going to go to 10. When I go to 10, I'm going to loop back up to the start, but it's going to say, and while I is less than 10. Integer 1 is no longer less than 10. Now I'm not going to go through this chunk of code. I'm going to skip this chunk of code and go to whatever's next. So that's our looping instruction. So important to know, we're going to use these two instructions, the if-then and the looping instructions, a lot in this course. Wait milliseconds. I bring this up right now because I think this might be one of the easiest ways for you to complete your homework for the week is to use the wait instruction. So a wait function is implemented suspending script execution for a set amount of time. When such an instruction is countered, script execution immediately stops and no more time is allocated to script execution until the milliseconds have elapsed. So if we're executing this code, we're reading left to right, top to bottom. Again, we're in mixed mode. This is going to tell me to drive straight. Drive straight. So I hit that code first. I start driving straight. My minibot is driving like this. And now he's over here somewhere. And he does that for a total of 5 seconds, right? So this is 5,000 milliseconds. So he's just going to continue driving because there's no other commands coming to him because we are paused in the execution of the code. We're not going to go on beyond that. But now when we get past that 5-second window of him driving straight, now we're going to, instead of waiting, because we executed this And now we're here. Now we're going to pick up the code again after 5 seconds. At that point, you can see what we did is our throttle went to 0 and we started turning to the right. So what he's going to do now is he's going to turn in place. He's not moving forward. If the throttle was still on, he'd be moving forward and turning. But now that he's throttle is 0 and he's turning to the right, what's going to happen is he's going to wind up kind of facing the other direction. I'm going to draw it to the side here, even though he's not going to move forward. So he's going to do some sort of turn in place like this. All right. And I don't know what, how fast 1,000 is going to get him. He might be facing this direction. He might be facing this direction. Unsure. But this chunk of code right here is probably going to be the chunk of code that gets you through this week's homework. So if you remember nothing else from this week, all you would have to add at the top of that would be option explicit. If you had this at the top and this chunk of code, you'd have the first step of your procedure written for this week. All right, so let's do I'm going to do a very, very brief demonstration. I don't want to do your homework for you. What I will tell you, so what we're going to do, I guess I can keep these for now. Oh, I didn't want to do that. That's fine. What you're going to do is you're going to write the code this week to take a robot that's going to start out here. This is the visit the 3 location map. The robot's going to drive over to this location. When he gets into here, he needs to wait 5 seconds. Now, I don't care if he's turned facing this way or this way while he waits. That part doesn't bother me. So you could get him into here and then have him sit here and wait 5 seconds. I'm fine with that. But he needs to visit that location, wait 5 seconds, and then he's going to drive down here and he's going to visit this location. And he's going to wait 5 seconds. And then he needs to return back up to here and park himself here. So it's really visit 3 locations. He started here and he needs to end here as well. That's where he needs to start and stop. Every time he gets to one of these squares, he needs to visit that square and he needs to wait 5 seconds. Okay, so you could simulate this as, you look at Amazon and the way their Kaiva robots pick up the bins and move them around. It could be a pallet jack that's moving material from receiving out onto the shop floor and then finished material back to shipping from the shop floor. There could be lots of examples where this is going to come in handy. So let's do this. I'm going to try to discard my ink annotations. Unfortunately, I kept all the other ones. I'm going to have to get rid of those here. Oh, they're actually pretty easy to get rid of. I thought that was going to be more difficult than it actually is. So let's open up the AGV sim. All right, and I'm going to, hopefully you've already downloaded everything. I'm going to start fresh. I'm going to start new. I'm actually going to open it from scratch even because I don't want to have any of the junk that I've been playing around with there. I'm just deleting my red stuff here so I don't forget later on. I don't want to have any of that stuff sitting there. Let me save this. Okay, get out of there. So what I'm going to do is I'm going to go into my AGV sim. Got all kinds of stuff going on. All right, Robo AGV sim. And what I'm going to do is I'm going to open up, hopefully you've edited or have downloaded that track. So that track, you should have it saved somewhere where you can find it. And then you can open up that visit 3 location track. It's in there. Now when you close that, it'll be your simulator, your vehicle will be in there. Now you'll notice it looks too big because it is too big. The next thing you should do is you should open up your configuration tree. And I want you to first select the board and go down to the bottom one, 2360. They don't actually have our SDC 2160, but the SBL 2360 is similar. So grab that bottom one. Then go to load profile. And wherever you saved the Minibot AGV sim profile, I also have that pasted on Canvas too for you can grab. Go ahead and open up that sim profile and then you can close. That's going to give you, just so you know, that's going to give you mixed mode and it's going to give you the characteristics that are most similar to our Minibot. Now your Minibot's much smaller and it only has one sensor on it that we're not using yet, but we will. And it's sitting in that first square. So now it's going to be up to you. How do I get it to drive and visit that second square? Well, I could go back and look at some of my code here. Like if I wanted to just start with this as an example, if I want to use this as my code, now I can go into my open code, and I'm always going to start out with option explicit, and then I'm going to paste some of that code in here. All right, and what I know this should be doing is this should be, and I do want to see you guys do this, is you should have some sort of program comments in here. And I would even go so far as to say up on the, even just up here somewhere, you could do it above or below, you know, even your name. So I'll put in my name, and I'll put in homework lab 1. And I might even put in like rev 1 or something like that, revision 001. You know, someone else can come in here and look at it and say, oh yeah, okay, this is EJ's code. I know it's mixed mode, so this is a throttle command. Maybe I'll even do that. I might even make it easier on me. Rather than saying drive straight, I might say this is my throttle command because I'm in mixed mode, and this is my steering command. That I think is even more valuable, especially as I'm just first learning this. What is my throttle command and what is my steering command? I think I should, there we go. I've got to wait, so this will wait 5 seconds. 5 seconds. And then I've got a turn. So again, this turn is just getting a throttle command of 0 now and a steering command of -100. I believe, right, we kind of went over this in the video here, that -100 I think is going to turn me in a clockwise direction. Well, if I wasn't sure, I'm going to find out, right? Most important thing in all programming languages, or anything for that matter, CAD or anything, save and save often. So I'm going to go to File, Save As. And so there's 2 of them here. This save just saves it in RoboAGV Sim. This actually allows you to save it in the folder. So I'm going to save it in the folder. And I'm going to call this HW-Lab 001. So I know what I've got here. I've got it saved in here. And now I'm going to test it. And it's as simple as just hitting that play pause and watch what your vehicle does. It goes for 5 seconds. And what did we just determine? Well, we determined that it drove forward for 5 seconds, and that was it. Now you might wonder, well, why didn't it make the turn? Well, first off, I probably could adjust that 5 seconds, right? I could probably say, well, 5 seconds was too much. Let's adjust that to 4 seconds and see what happens, right? I'm just going to hit save. I'm not going to save as, and then hit play. And now 4 seconds. Maybe that gets me in that. Well, it's pretty close, right? Why didn't it turn though? Well, the reason it didn't turn is because we gave it that throttle command. But how long did we give it that throttle command? How long was it working with that throttle command? Because what it really did was it turned this throttle steering on for 4 full seconds. And it turned this steering command on for whatever the scan cycle was of it going through the logic. So I might need to put in a wait here. Maybe I want to put in a wait of, let's put in a wait of 4,000 again. Let's see what happens here. Let's wait 4 seconds after we issue that steering command just to see what happens. So we get down here. Oh, now we get a steering command. What do we notice about 4 seconds? That's probably a little too long, right? Because we did, instead of turning 90 degrees, we turned like 290 degrees or something like that, right? So this is where you're going to play. Right now you have enough, just in what I've shown you here, to really get started just giving this. Now this is open loop, right? This is going to be our open loop 3 locations, right? I'm not a fan of this, right? In the real world, what would I want? I'll hit save as, make sure I got this save over the top of it, looks good. Normally I wouldn't want to do it this way. And if you ever want to reset it, you just hit this little reset, and then you can start it up again, right? Maybe I'm thinking, oh yeah, this is probably going to be, instead of 4,000, it's 3,000, You know as well as I do that that's not enough, but let's just play it. But by doing this, I can do a number of different things. I can try different things and see what they do, and I can reset them and change the variables and go on and go forth. In the real world, what we're going to do, we're not going to do this open loop. because there's no way to know if this thing had a little slippage or something. Did it, it may work great in the simulation environment, and then you put it out on the shop floor and it misses this mark by, by a meter or something, because the floor, the friction of the floor, this simulator assumes all variables are perfect, right? There is no friction, there is no slippage, there is no changing of weight or elevation or slope of the floor or anything. None of that stuff affects us because it's a perfect simulated environment. So that's what you guys will work on for the homework. Let me see if I can pull that up real quick here and show you what that looks like, and then we'll be in a good spot. Labs, I've got this listed as homework lab 1. All right, so here's just the information on it. I will tell you that the MicroBasic Scripting Manual, you can find that on Google, and that's going to come in really handy for you. This lecture, of course, is the one you want to be looking at. This is what I'm asking you to do. There's some pre-lab questions defining the difference between open and closed loop. Type those answers right into the Word document, and you can email this back to me. Describe the difference between separate and mixed mode motor controllers. Code necessary to turn in clockwise direction using separate, and clockwise direction using mixed mode. And I don't care when you do like separate, I don't care what the numbers are, just as long as it's turning in the right direction. And same with the mixed mode, as long as it is making the turn in the right direction. You can test those. What are the 2 data types available in MicroBasic, and name at least one benefit and one detriment to not having real numbers as a data type. And then this is your lab activity. Once you have your code written and you're happy with it, it is important that you paste your code into the text box below before submission. So here is the text box where I want you to paste that code right down here. And then what I will do is, once I get your submission, and if you need to put this text box on the second page or something like that, or onto another page, that's fine. Just make sure you get me all your code, and I don't even care necessarily how big the code is, as far as font size. Don't make it tiny. But I'm just going to take whatever code is in here. I'm going to highlight it, paste it, and then I'm going to go right into the Robo AGV Sim, and I'm just going to paste your code right in here is what I'm going to do. So just keep that in mind, and that's the way I will grade it. Is I want to make sure that the robot is hitting the center of these squares. All right. If it's a millimeter off, I'm not going to kill you. But if it's making the turn over the boundary of the square, you'll probably lose a point, or whatever the case is. Then you got to decide too, how do you want to get back? So you visit this square, wait 5 seconds. You visit this square, wait 5 seconds. You could drive this way and then up, or you could just beeline in a diagonal direction and up. I do want to make sure though, every time you're in a square, you're in the center of that square, and no part of the vehicle is touching the boundary. So this is where we're allowed to park when we are parked, whether it be in that square, this square, or this square, and also turn. If we're turning, we can turn in there, but we should not be crossing that boundary until we are navigating to that next square. So with that, I think that concludes. Let me just make sure there's nothing else I want to look at here. No, I think that concludes MicroBasic Lecture 2, and I hope you guys have a great week this week. Feel free to email me or call me with any questions that you may have. Thanks.